All right, today we are going to look at one of many ways that we can solve linear systems. So before we jump into this lesson, let's review really quick what a linear system is. So a linear system is a system of two or more equations, although we've just been looking at two equations here. And when we solve a linear system, we are trying to find the point or the ordered pair that is a solution to both equations. So down below here, we would see this is an example of a linear system. Those two equations there, we have an x and a y. And to solve this linear system, we are trying to find the point or the ordered pair that is a solution to both equations. In other words, when we plug it into each one, we get a true statement. So one way that we've learned how to solve these is with graphing, where we graphed each line and we looked for the point where they intersected, because the point where they intersected is the point that is the solution to each equation. And today we're going to look at another way that we can solve these linear systems, and that's called using substitution. Now, the nice thing is the names tell us exactly what we're going to do. We're going to be substituting here to help solve this. So in the steps above, we'll talk through this, and then I think once we walk through an example, it will make even more sense to you. So the first thing we're going to do is solve one of the equations for one of its variables. So in other words, in one of the equations, you either need to isolate x or you need to isolate y. Sometimes that's already happened for you. But sometimes you're going to need to do a couple steps to do that. The second step is that we substitute the expression that we got from step 1 into the other equation. In other words, if we isolate y, we're going to plug what we got y to be in for y in the second equation. And what that's going to do for us is it's going to give us an equation that only has one variable instead of two. And if it only has one variable, then we know how to solve that. We're able to figure out what that one variable is. Once we know one of the variables, either x or y, we will plug that into either of the equations to figure out the other one. All right, again, once we walk through this step by step, I think it'll make a little more sense to you. All right, so let's take this first example. Here you can see our two equations. Now, in this example, step 1 is already done for us because if you notice, in equation 1, the y is already by itself. So equation 1 is already solved for y. We have isolated that variable. You see it right there. We didn't need to do anything. So we can jump straight to step 2. And that is now that based on equation 1, I know that y is 3x plus 2. So I can take that 3x plus 2 and plug it in for the y in the second equation because, again, I just found that that's what y equals. So I'm going to take my second equation, x plus 2, but instead of y, I'm going to plug in 3x plus 2. Again, I am substituting what I found y equals into the second equation. Do you see that there? I'm taking this 3x plus 2 and I'm plugging it in for that y. Now, again, what I have accomplished here is if you look at this equation now, you have an equation that only has x's. And so we know how to solve this. We can start by distributing. Then I can combine like terms. I'm going to subtract 4. I'll come up here because I'm running out of space, and I get 7x equals 7. Divide each side by 7, and x equals 1. So I'm now halfway to finding my solution because I now know that the x coordinate is 1. Okay, so now I'm going to jump and try to figure out what the y coordinate is, and I can do that by plugging in x into either equation. So I'm going to plug it into the first one. So this would be 3 times 1 plus 2, which is 3 plus 2, so y is 5. Just so you know, you could have plugged it into the second equation. You would have gotten the same thing. I'll show you that. You obviously don't need to do this work each time, but I just want to prove to you that it doesn't matter which equation you plug it into. So here I would have 2y equals 10, which when I divide each side by 2, I would also get y is 5. So again, it doesn't matter which equation you plug it into. So now you have your x coordinate and you have your y coordinate, so you have your answer. The solution is 1, 5. That is the ordered pair that is a solution to both equations. Now, I'm not going to require that you always do check steps, but on the first couple here, I want you to see why this solution works. And I always encourage you that even if you just kind of do it in your head or just really quickly, it's always good to check that you have found the right solution. So into each of my equations, I'm going to plug in 1 for x and 5 for y and make sure I get a true statement. So the first equation would be 5 equals 3 times 1 plus 2. So this is 5 equals 3 plus 2. So 5 equals 5. Yep, that's a true statement. In my next one, I have 1 plus 2 times 5 equals 11. So this would be 1 plus 10, and that is 11. And so you'll notice, because I got true statements for both equations, I know that I found the right solution, which is the ordered pair 1, 5. All right, let's go on to another example. Here we see our linear system, and you'll notice on this one, neither equation is x or y by itself. So we are going to need to do step 1, and it honestly doesn't matter how you do it. You could either in equation 1 isolate the x or isolate the y. In equation 2 you could isolate the x or isolate the y. So there's lots of options here. You always want to look and see what looks like it's going to be easiest or take you the least amount of steps. And so as I look at those two equations, I think it's going to be easiest to get x by itself in that first one. So that's what I'm going to do, because I always like to choose the easiest path if I can. So to do that, I need to add 2y to each side. That gives me x equals 2y minus 6 or plus negative 6. Okay, so now my x is by itself, and I know that x is 2y minus 6, and so I'm going to plug that in for x in my second equation. I'm substituting 2y minus 6 in for x, because that's what I found that x equals. Okay, so I have 4, but instead of x, I'm going to put 2y minus 6, and then plus 6y equals 4. Again, I'm taking what I found x to be and substituting it in for the x in the second equation. And again, what you notice here is I now have an equation that I can solve because it only has one variable. In this case, it has y. It doesn't matter if you find y first or x first. It's going to work out the same for you. So I'm going to distribute. Then I'm going to combine like terms. I'm going to add 24 to both sides. Got to come up here because I'm out of space. I get 14y equals 28. Divide each side by 14, and you get y equals 2. So again, you're halfway there because now I know what one of my coordinates is. So I'm going to substitute 2 in for y into either of the initial equations. So I'll just do the first one. I have x minus 2 times 2 equals negative 6. So that's x minus 4 equals negative 6. I add 4 to each side, and I get that x equals negative 2. Again, you don't need to do this, but I'm just going to show you that you could have plugged it into the second equation and you still would have gotten the same thing. When you're solving these, you don't need to plug it into both. Again, I'm just trying to prove to you that it works either way. So here I would subtract 12. That gives me 4x equals negative 8. You divide by 4, and you see that, again, x is negative 2. So either equation that you plug it into, you get the same thing. And so now I have my x coordinate and my y coordinate, so I know my answer is negative 2, 2. Make sure when you write your ordered pair, you go in the order x, y. The x coordinate first, then the y coordinate. All right, again, we're going to check this. You aren't required to check them, but it's always a good just to really quick make sure that you got the right thing. So I'm going to first plug it into the first equation. I'm making sure I get true statements here. So I have negative 2 minus 2 times 2 needs to equal negative 6. That's negative 2 minus 4. Keep change if you want, and you get negative 6 equals negative 6. So that one worked. Over here, I have 4 times negative 2 plus 6 times 2 needs to equal 4. So that's negative 8 plus 12, and that does equal 4. So I see that it works. Now on this one, we're actually gonna do a double check, which of course you're not normally gonna do. But what I wanna prove to you is it doesn't matter what method you use. So if you had used graphing, like we learned earlier, you would get the exact same answer. So we're finding the same answer, we're just finding it a new way. Okay, so let's say on this one that I wanted to graph it. So I am going to take my first equation, which is x minus 2y equals negative 6. I'm going to write that in slope-intercept form. So I've got to get the y by itself. I'm going to put a 1 in front of that x. Divide everything by negative 2, and I get y equals 1/2 x plus 3. So I know my slope is 1/2. And my y-intercept is 0, 3. So I can put 0, 3 and go up 1 over 2, or down and left. So there's my first line. Then I'm going to take my second equation, which is 4x plus 6y equals 4. Make sure I got that right. Yep. Okay, again, I need to get the y by itself. So here I've got 6y equals negative 4x plus 4. Divide by 6. And I get y equals negative 2/3 x plus 2/3. Okay, so this one, you can see right away, this isn't ideal to have to graph this one. We still can. So I'm going to kind of put the 2/3 there as my y-intercept, and I'm going to go down 1, 2, right, 1, 2, 3, or I can go up 1, 2, and then left 3. And so again, you absolutely can graph this one. You see this one's not as ideal to graph because the y-intercept is not a whole number, but you can. And when you do that, hopefully what you notice is where these two lines intersect is at the point negative 2, 2, which is the exact same solution that I found through substitution. So again, I'm just trying to prove to you that it doesn't matter what method you use, either method is going to get you the same answer. All right, now let's try a couple more. So looking at number 1, you'll notice that on number 1, the y is already by itself. We know that y is 2x plus 5, so that's great. We don't have to do step 1. And the first thing we can do is plug what we know y is into the second equation. So that gives us 3x plus 2x plus 5 equals 10. Again, I'm substituting that in. Then I have an equation with only x's, so I can start solving that, trying to get x by itself. So this gives me 5x equals 5. So I know x is 1. So I'm halfway there. Now I need to figure out what y is, so I can plug that x into either equation. I'll go ahead and just plug it into the first one. So here I have y equals 2 times 1 plus 5. So y equals 2 plus 5, which means y equals 7. And so again, don't stop there. Remember, your answer has to be an ordered pair. In this case, it would be the ordered pair 1, 7. Now, again, you don't need to do like a formal check step, but I always think it's good just to do a quick double check to make sure that it works. So here I would have 7 equals 2 times 1 plus 5, and I can see, yep, in that case, 7 does equal 7, so I'm good. In the second equation, I have 3 times 1 plus 7 equals 10, and so, yep, I can see I get 3 plus 7 is 10, which is true. So again, you don't have to do a check step, but I think it's always good just to kind of plug them in real quick and make sure it works in both equations. All right, let's try number 2 now. So in number 2, neither, like I don't have an x or a y by itself in either one. So I'm going to look, and in this situation, actually, you could pretty easily get x by itself in the first equation or the second equation, so it truly does not matter what you do. Either way, it's going to work. I'm going to go ahead and isolate it in the first equation. So when I have x minus y equals 3, to get the x by itself, I'm going to add y to each side. and I get x equals y plus 3 or 3 plus y, it doesn't matter. So now that I know what x is, I'm going to plug that into the second equation. So I get y plus 3 plus 2y equals negative 6. Combine like terms. Subtract 3. Divide by 3. And I now know that y is negative 3. So now that I have y, I can plug it into either equation to get x. I'm going to go ahead and plug it into the second one just for fun. So I get x plus 2 times negative 3 equals negative 6. So x plus negative 6 equals negative 6. I'm going to add 6 to both sides, and I get x equals 0. Okay, now again, be careful that you always go in the order x comma y. So this would be the point 0 comma negative 3. And again, when you plug that into the first equation, you see you'd have 0 minus negative 3, and that's the same as 0 plus 3, so that is 3. In the second equation, we have 0 plus 2 times negative 3. 2 times negative 3 is negative 6, plus 0 is still negative 6. So yep, that works. All right, so why don't you right now pause the video and try number 3 and 4. When you're ready to check your answers, press play to check how you did. All right, go ahead and check your answers with mine. On the first one, I got y by itself in the first equation because that looked to me like the easiest way to do it. And then I plugged that into the second equation and ended up with the ordered pair negative 2 comma negative 1, which when you plug that back in, you'll notice that it checks out in both equations there. And then on the second one, in the first equation, y was already by itself, so that was great. I just went ahead and took that 2x minus 1 and plugged it in for y in the second equation, substituted it in, solved for x and then for y, and got the ordered pair 1 comma 1. So hopefully this makes sense to you, and now you see another way that you can solve linear systems using substitution. Have a great day.